Hello class, today what we are going to look at is bisectors of triangles. Now in our previous videos we looked at the perpendicular bisectors of segments and we looked at the angle bisectors of angles. So we looked at the perpendicular bisector theorem, angle bisector theorem. What we're going to look at today is how those apply when they are within triangles. Okay, so in a triangle, the perpendicular bisectors, this is the perpendicular bisector of each of the sides, are concurrent. Concurrent, for those of you who have forgotten what that means that they all come together at a single point called the point of concurrency. Okay, now, so here you see segment PE, that really ought to be marked, so I'm going to go ahead and mark it, is the perpendicular bisector of side BC. Segment DP is the perpendicular bisector of segment AB, and segment PF is the perpendicular bisector of segment AC. All right, and you see they all come together right here at point P, and point P is called the circumcenter. Okay, circumcenter. And before, the perpendicular bisector theorem says that any point on the perpendicular bisector is equidistant from the endpoints of the segment, right? Which means point P is equidistant from B and C. But it's also on this perpendicular bisector, which means that it is equidistant from A and B, and it is on this perpendicular bisector, so it's equidistant from A and C. So what that means is the circumcenter is going to be equidistant from all three vertices. All right. So the distance from P to B is the same as it is from P to C. It's the same distance from P to A. Okay. And this is the circumcenter. The reason it's called the circumcenter, it comes from two things: center being the center, obviously, and circum, which means to go around. Okay. So for example, to circumscribe something means to draw around. To circumnavigate means to go around it. To circumvent means to bypass something, to go around whatever it is that's going to happen. All right. Circumcenter is because it is the center of a circle that is drawn around the triangle. Okay. So if we drew a circle around the triangle, to circumscribe means that it's going to touch all of the vertices just perfectly, just going to touch the vertices. And this is drawn around the triangle, and the circumcenter is the center of that circle. All right. Now, if you'll notice, if you have an acute triangle, my circumcenter is right here. But if you have a right triangle, notice it moves over to here. It's right on the triangle, and specifically, it is on the circumcenter will be at the midpoint of the hypotenuse of your right triangle. Okay? And if you have an obtuse triangle, though, notice the center of this triangle, the circumcenter, is not even in the triangle, which is always fun when something's center is not even in the triangle. All right? So that's the circumcenter. The circumcenter is formed by the intersection of the three perpendicular bisectors, and it will be equidistant from the vertices of the triangle. Now, we're also going to talk about angle bisectors. So let's take a look at this. Angle bisectors are also concurrent. Okay, so we have angle bisectors here. That's an angle bisector. This is an angle bisector. And here we have an angle bisector. All right. The angle bisectors, we said, were equidistant from the sides of the angle, which means that point P, since it is on the angle bisector for angle C, that means it is equidistant from point E and from point F. All right? Remember, these distances are always going to be perpendicular. Shortest distance between a point and a line is a perpendicular segment. All right? So those two are going to be congruent. Now, point P is also on the bisector of angle B, which means it is equidistant from BE and BD, so these are also going to be congruent. It is also on the perpendicular bisector of, it's not the perpendicular, the angle bisector of angle A, which means it is equidistant from side AD and side AF, so those two are congruent. And so you'll notice this point, which is called the incenter, is going to be equidistant from the sides of the triangle. Not the same distance from the vertices, but this is going to be the same distance from the sides. Okay, so the intersection, this point of concurrency of the angle bisectors, is called the incenter, and it is going to be equidistant from the sides of the triangle. The reason it's called the incenter is because it is the center of a circle that is drawn inside the triangle, so that it touches all three sides. Now, since this circle is drawn inside the triangle, the incenter will always be inside the triangle. Will never be on the outside like the circumcenter was. All right, so let's take a look. Let's see what all we can do. I'll open this up. All right. In exercise 1 and 2, it tells us that N is the incenter of triangle ABC. We want to use the given information to find the indicated measure. Okay, so it is the incenter, which we just said means that it is on the angle bisectors, and it is also the same distance from all three sides. Okay, so let's take a look at this. We have ND, we have NE, so let's see, ND and NE. We want to find NF right here. That's what we're looking for. Okay, so we know this is 2x minus 5. We know NE is negative 2x plus 7. And since this is on the incenter, that means all three of these are congruent. All right, which means 2x minus 5 equals negative 2x plus 7. So 2x minus 5 equals negative 2x plus 7. We want to solve this for... All right. So let's see here. First thing we need to do, we need to get all of our x's to one side. So I'm going to add 2x to both sides. And then I'm going to move my 5 over here. So add 5 to both sides. That cancels out. That cancels out. And I am left with 4x equals 7 plus 5 is 12. Divide by 4. And x equals 3. But it didn't ask me to find x. It asked me to find the length of NF. I don't have NF, but NF is the same as ND, it's the same as NE. So if I know how long either one of these is, then I know how long NF is. So I just could take my 3, plug it into whichever one you want. I'm going to go with ND because it's positive. So that is 2 times x, which is 3, minus 5. 2 times 3 is 6. 6 minus 5 is 1. So NF equals 1. All right, so not too bad. Okay, what I would like you to do, pause the video and work out number 2, and then come back and check your work. All right, you're back, so let's see how you did. Okay, so we have NG, we have NH, we need NJ. It is the incenter. N is the incenter of the circle, of the triangle, which means all three of these points are equidistant from point N. So these are all congruent to each other. So I can set those equal to each other. So x minus 1 equals 2x minus 6. Okay, so let's solve this. Get all my x's to one side, so minus x. Then I'm going to move my 6 over there, so plus 6. That cancels out, and I am left with negative 1 plus 6, which is 5. 2x minus 1x is x, so x equals 5. Again, it did not ask me for x, it asked me for nj, which it doesn't tell me, but that's okay, because nj is the same as either one of those. I'm going to plug into ng because that looks really easy. So I have x, which is 5, minus 1, which equals 4, and that is going to equal nj. So not too bad. Pretty easy stuff. Okay, so let's take a look at this next set. Okay, so for numbers 4 through 7, find the indicated measure. So it's not telling you you're at the incenter, it's not telling you you're at the circumcenter, it just says find the measure. So you got to figure it all out. which is fine because we can do that. So we are looking for the length of segment PA, which is this segment right there. We want to know how long is that segment. So we have point P right here, and let's take a look at what we've got. We've got a lot of perpendicular lines, we've got a lot of stuff congruent. So let's see, perpendicular lines, congruent there, so that means this is a perpendicular bisector, this is also a perpendicular bisector, perpendicular bisector. So since these are all perpendicular bisectors, that means that we are on the circumcenter. And as we said, the circumcenter is equidistant from the vertices, which means the distance from P to A is the same as the distance from P to B. So these are congruent, and so that means PA, very simply, is going to be this 13 right there. That was simple. Okay, let's take a look at number 5. On number 5, are we still on the perpendicular bisectors? Well, they are perpendicular, but are they the bisectors? Not perpendicular bisectors, not marked that way. Okay, so let's see. We're looking for segment PS, which means that's what we're looking for. But we are on angle bisectors. Angle bisectors, which means we are on the incenter, which is equidistant not from the vertices, like P was over here. What this means is we are now equidistant from the sides. That means a perpendicular line from the side through the point is going to be the same on all 3 of these, which, oh, there it is, it's 8. These are all congruent, which means that PS equals 8. Because it is on, these are angle bisectors, so it is in the incenter. So far, pretty easy, not too bad, not too bad. Let's take a look at the other ones. Let's see, because the instructions were for 4 through 7. So here we go. Number 6 looks a tad bit more complicated. Okay, let's see here. We are looking for segment GE, which is right here. Okay. GE is there. Let's see, there's G. We have a 10 over here, and you see how we can use it. Let's see, ED. Well, look at this. This segment here is perpendicular, and it is a bisector. It is also on the perpendicular bisector there, perpendicular bisector there, which means it is equidistant from all the vertices. So, from G to E is the same as the distance from G to D. These two are congruent, and so GE equals 10. All right, last one. We need NF, which is right here. Are we looking at the incenter, or is this the circumcenter? Are we on the angle bisectors or the perpendicular bisectors? We do have perpendicular lines there, but we also have congruent angles. Notice these perpendicular lines are not bisectors. Right? This side is not congruent to that piece. None of these are congruent to each other. So, angle bisectors, this is the incenter, which means we are equidistant from the sides. So, segment NF is going to be congruent to segment NE, which means NF is going to equal 2. All right. So far, nice and easy. Not a whole lot of stuff there. Pretty easy to deal with. Now we get to the complicated stuff. All right. Find the coordinates of the circumcenter of the triangle with the given vertices. All right, so we need a triangle with those vertices. A lot easier to do if we can see the triangle. So we're going to draw these on there. Let's see here. We've got some positives, we've got some negatives. So we will just put this here in the middle. Let's see, we need to go to positive 6 on the x, so I'm going to move it over here. Not quite in the middle. Let's see, 1, 2, 3, 4, 5, 6, and we'll go over 1 and just go, yeah, that'll fit. Okay, so I need an axis. Put my axis right here. And let's see, positive 4, negative 2, so I can put that in the middle. That'll work. Close my grids 10 by 10. Okay, so now let's draw this triangle in. We need negative 2, right there. That is point A. Negative 2, positive 4 is point B. Positive 6, 1, 2, 3, 4, 5, 6. And positive 4 is right here. point C. Always use a straight edge to draw stuff. All right. Now, we are looking for the circumcenter. So was this looking at angle bisectors or perpendicular bisectors? That's right, this is the perpendicular bisectors. Okay, so perpendicular bisectors, let's actually take a look at this. So circumcenter is perpendicular bisectors right here. And notice on a right triangle, it's going to be on the hypotenuse. This is a right triangle. So our answer is going to be somewhere on this hypotenuse. We've got to find the perpendicular bisectors to figure out exactly where this is. So first off, bisect. Let's find the midpoint. And we'll just do BC first because it's horizontal and that's easy to do. 1, 2, 3, 4, 5, 6, 7, 8. So it has a length of 8. So half of that would be 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we're going to go right here, and we need something that is perpendicular to a horizontal line. Well, perpendicular to a horizontal line is a vertical line. So that's going to go this way. All right, perpendicular. Now we do BA. We find the midpoint of BA, and we could use the midpoint formula, but it's on the grid line, so we can just count it. 1, 2, 3, 4, 5, 6. Half of 6 is 3, so 1, 2, 3, right here. It's a vertical line, so we need a perpendicular to a vertical line, which is a horizontal line. So, like so. These two both intersect right here. Well, all three of these are going to intersect at the same point, so we really only need 2. We don't have to do the third one. We could if we wanted to, but we don't. There it is. Right there, where 2 of them intersect, the third one will also intersect. So this is our circumcenter at the point 2, 1. 2, 1. And that's our answer. All right, so real quickly, let's go ahead and do the next one. All right, let's see here. These are all positive numbers, so I can put my axis way down here. So I'm just looking at the first quadrant rather. Alright. Now we plot our points. 1, 2, 3, up 5. That is point D. The next one is at 3, 1. Point E. And the next one is at 9, 3, 4, 5, 6, 7, 8, 9, and 5, which is right there. That is point F. Okay, so again, we have a right triangle, which is very easy to do, especially if the legs of the triangle are on the grid line, which these are. Because now all we have to do is count. 1, 2, 3, 4, 5, 6. Half of that would be 3 right here. Perpendicular to a horizontal line is a vertical line. And 1, 2, 3, 4. Half of that is 2. There, so there's our midpoint, and perpendicular to a vertical line is a horizontal line. And so, again, where those two intersect is where all 3 will intersect. And there's our circumcenter at 1, 2, 3, 4, 5, 6, and up 3. So at the point 6, 3. All right, so there is perpendicular bisectors and angle bisectors in triangles. Remember, perpendicular bisectors intersect at the circumcenter, which is equidistant from the vertices. Angle bisectors intersect at the incenter, which is equidistant from the sides. All right. Hopefully that was helpful, and I'll see you next time.